Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationct.com. In this film, we focus on creating an initial solution in minimum cost flow problem with a simple example. Let's move on.
To create an initial feasible basic solution, we can use the method when it's challenging to such a solution, especially for a large network. This method includes introducing an additional node called V sub n plus 1. For node with the supply, we connect them to the Vn plus 1 by adding an arc with the cost of 1. On the other hand, for nodes with a demand or intermediate node, we connect Vn plus 1 to those nodes with the arc having the cost of 1. The remaining arc have a cost of 0. Next, we apply the simplex method to this network until the value of the objective function becomes 0. Once we reach this point with the objective function of 0, we have obtained an initial basic solution. We can proceed with the simplex method using this solution as a starting point. To find an initial basic solution for the given network, we can follow this step. So we create an artificial node called node 7. Connect node 1 to node 7 with the cost of 1 and the node capacity over arc 1, 7. And create arc from node 7 to all other nodes with the cost of 1. So 7.2, 7.3, 7.4, 7.5, and 7.6. The cost of the other arc is equal to 0. The resulting basic solution is as follows. This is the initial basic solution for the simplex method for finding initial feasible solution. There are, as you see, there are arc from 1 to 7 and 5 arc from 7 to 2, 3, 5, 5, 4, and 6 with the cost of 1 and no capacity. So assuming y7 is equal to 0, we can calculate the yi coefficient based on the equation here. Cij minus yi plus yij is equal to 0 for all basic variables, our basic arc. So as we can see, we can calculate y1 to y6 and y7 is equal to 0. The cost of the Cij bar for all non-basic arcs is as follows. Because arc 1, 2 is at the lower bound and does not satisfy the optimal condition, it enters the base. So output arc can find using this process, as we stated in the earlier example, the arc 7, 2. Okay, the arc 7, 2 is removed from the base and resulting as a result, and arc 1, 2 enter the base. And this is the current basic solution. In this iteration, the value of the objective function is equal to 4t. Assuming again y7 is equal to 0, we can calculate the value of the yi for all nodes using the equation Cij minus yi plus yj is equal to 0. So we can calculate the Cij bar again for all non-basic arc as follows. Because arc 1, 3 is at the lower bound and does not satisfy the optimality condition, it enters the base. The output arc from the base can determine from this process. Arc 7, 3 is removed from the base and arc 1, 3 enter the base. As a result, this is the next basic solution with the objective function of 14 again. Assuming y7 is equal to 0, we can calculate the value of the yi for all nodes here from y1 to y6 and y7 is equal to 0. The cost of Cij for all non-basic arc is as follow. And you can see that the arc 2, 4 is at the lower bound and does not satisfy the optimality condition. So it enters the base, and the output arc can find using this process. So arc 7, 4 is removed from the base, and as a result, and arc 2, 4 enter the base, and as a result, this is the next basic solution with the objective function of 14. Assuming again the y7 is equal to 0, we can calculate yi coefficient using this equation. And this is the yi value for all nodes. Then we can calculate the Cij bar for all non-basic arc, and you can see that arc 4, 6 is at the lower bound and does not meet the optimality condition. So it become a part of the base. Let's determine the output arc. You can see that the output arc is where with the theta of 10, the arc 4, 6 enter the base, but quickly reach at the upper bound because the capacity of this arc is 10, and remove again from the base. As a result, this change, the current solution is updated as a follow here, but we have the same basic solution with the last iteration. So you can see that the list of the basic arc for this iteration is equal to this arc. As a result, we again calculate the Cij bar for all non-basic variable. As you can see that arc 4, 6 has reached its maximum limit and fulfilled the optimal condition. So we cannot consider this arc again for entering the base, but we can enter arc 3, 5 because it's at the minimum limit and does not meet the optimality condition. So it entered the base, and find how we can find the output arc by doing this process. And we can see that we add arc 3, 5 to the base, and arc 7, 5 is not longer part of the base, which lead to current basic solution as a follow with the objective function of 20. Again, we calculate the yi for all nodes, and we then calculate Cij for all non-basic arc as a follow. Because arc 5, 6 is at the lower bound and does not meet the optimal condition, again it entered the base, and let's determine the output arc using this process. So you can see that here, okay, the arc 1, 7 removed from the base here, arc 1, 7 removed from the base, and this is the basic solution for this iteration, and the objective function in this iteration is equal to 0. Assuming y7 is equal to 0 for, and calculate yi for all nodes, we can now calculate Cij. Now let's consider the cost of the non-basic arc, which as follow. The optimal conditions are met because the all Cij for all nodes for all non-basic arc meet the optimality condition. So we reach the optimal solution with the objective function of 0. So it means that this is the this is the final or optimal solution for this network, and we can use here the this solution for the initial solution for finding the minimum cost flow problem for this network here. Let's see. Okay, here. So we can use that initial solution for finding the optimal solution for this network. So this is the process we can use the initial basic solution for the challenge network. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by form by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.